So our next presentation is by Tom Sandra, as I mentioned, and Tom is a software guru, open source fan, and developer. Tom has more than 20 years professional programming experience in a range of languages. Tom's experience has been varied, but his focus is on C++ and Linux. Since 1998, Tom has been involved in various open source projects. His first big application that was released was part of KDE in 2000. Tom has been involved with Bitcoin since 2013 and has worked with financial companies to learn more about economics, money, and fintech. Tom is currently working on Bitcoin Classic and will also talk about flexible transactions.
Bitcoin Classic was started as a response to the market need for bigger blocks and an alternative developer group to provide it as a primary and first way to get Bitcoin to scale to the next million. Since that first release in February, we have come a long way. The Bitcoin landscape has changed, and mostly for the better, and I think this is an accomplishment a lot of us can be proud of. Our two main goals were to have more distributed development and to have bigger blocks. I think we're a lot closer to both ideals, but there's more work to be done. I personally started this journey some 3 years ago. I tried the code that was Bitcoin Core and wanted to improve upon some things that annoyed me. Now, 3 years later, I have seen every file and most of the code of what is in Bitcoin. I think it's a very rewarding problem to study, and it can occupy one for years. I have to restrain myself whenever somebody now asks the basic question of what is Bitcoin? My mischievous self would answer that it would take a week to explain the whole thing. My primary role in Bitcoin Classic is one of release manager. This essentially means I take the responsibility to get the highest quality releases. Next to that, I love to innovate and write code. I've been doing a lot of that over the last months. So why did I title this Classic is Back? The truth is, it never really went away. I think it's fair to say that Classic stepped aside when the 2 megabyte Band-Aid solution we shipped caused a lot of market response, discussion, but Classic has always been there. Busy coding, busy improving things. One of the changes we have seen in the market is a change in understanding how all Bitcoin software can work together. This idea has been used so many times before, it stood the test of time already. It's about how we can limit without setting a limit in software. All software, when it's immature and only targets a small amount of users, has limits built in. These limits are really there because the author learned that his software is not good enough to do more, and a limit is by far the easiest solution. This design isn't uncommon. The older ones among us may remember that MS-DOS had a memory size of only maximum 640 kilobytes. Email so many years ago had a maximum size of 1 megabyte. As part of growing up of that software, better solutions are found that then make those limits obsolete. The limits were removed and people were happy. Now, it's important to realize that removing of limits in software doesn't automatically make them unlimited. It just makes other costs limit the actual size. You still can't send a DVD-sized email. The maximum size is now determined by the market, a basic calculation of cost and benefit. So let's take a quick look at the market incentives that a Bitcoin miner has. On one hand, miner mining bigger blocks are nice because he gets to pick up more fees. On the other hand, smaller blocks are nice to keep a bit of scarcity and have people still paying fees. Also, bigger blocks cost more time to send and make the chance of orphans higher, both of which are costly. On the other hand, smaller blocks cause a bigger backlog, and as a natural result, that suffers to paying customers. we want to avoid losing them to the competition. These are all conflicting incentives. There are both reasons for bigger and there are reasons for smaller blocks. The end result will be that blocks will have a size set based on the market demand for space in those blocks, simply because that's the most profitable for miners to do. And the good thing here is that the best situation for miners is a pretty darn good situation for everybody else in Bitcoin as well. What Andrew Stone came up with is that everyone publishes the maximum size they are willing to accept. And this makes the market for block sizes become an open market. Now miners can decide what the ideal block size is without fearing that their blocks will be rejected by other miners for being too large. A purely market-driven block size is a big change for Bitcoin, and it may take longer for everybody gets used to it. And in the meantime, Classic is working on several next generation projects. The network manager or admin server. In Classic, I started a project that is the network manager, a replacement network layer that solves many of the problems we have with the current peer-to-peer code we inherited from the Satoshi client. On top of this is currently being built an admin server. The admin server will fill the role of a remote control. You can create transactions, query the blockchain, sign data, and ask it to make coffee. All but the last one are already present, and this admin server just uses the existing functionality from the Bitcoin command line CLI app. The place where this shines is in the speed that is various magnitudes faster, and it allows not just asking questions like a web server, but the admin server's live connection, and it pushes out data, for instance when a new block comes in. So it enables a new set of network enabled tools that can be created with it. Some examples where it's going to be used are application management software, which monitors any number of nodes under its control for warnings and slowness, but also for operational statistics like how many megabytes have been sent. Scientific research to query the entire blockchain without having to store it locally. Much faster uploads of big blocks from a miner to a full node. This project is nearing its 80% completion. Do you think Classic is back on track? In the original Bitcoin 0.1 release, Satoshi Nakamoto included the design that is a very good indication of his intentions for the future. He included a version field for transactions. Every single transaction on the blockchain has a version field in it. Today, 8 years after the fact, we are still using the exact same format, as indicated by the version number, as was introduced all those years ago in version 1 of the transactions. We are not really using this version field that Satoshi provided. And there are plenty of problems we have in Bitcoin's design which would benefit immensely from actually being able to make fixes in the transaction format. And flexible transactions is a protocol upgrade that is meant to make that happen. The flexible transaction protocol has been under development for a couple of months now, and we currently solve quite a lot of issues in the first version. Among these are malleability fixing, linear scaling of signature checking, hardware wallet supports, very flexible future extensibility, so we don't have to do this kind of change again anytime soon. Double spend proofs, makes transactions smaller. It supports the Lightning Network, and it supports future script version increases. So where are we now? The flexible transactions code is running on a net testnet. The functionality is also about 80% done. We definitely have some more tests to run. Bitcoin Classic is definitely back. Bitcoin Classic is based on the 8-year-old Satoshi codebase. I myself have been spending more time than expected learning this codebase. And I know from some other developers that I'm definitely not alone. The codebase is not even that large. The most often heard complaint is that it lacks a modular design. And the thing here is that hard to understand code leads to lower quality projects. This is very simple to understand. Programmers are just human and they make mistakes when they have to create clean code in a dirty environment. I think it makes a lot of sense to have a focus on improving architecture and code quality in Bitcoin Classic. The goal is to help developers understand the code faster and at the same time help our products to be of higher quality. The various products I mentioned today are all based on common and reusable technologies. The introduction of the common message format will be the common layer between the flexible transactions, the network manager, and the admin server as a quick example. It feels very important to work on all of these improvements together with other teams that are part of Bitcoin. They have their own improvements, and in the end we want to reuse each other's innovations and ultimately code. I have had many good conversations with people like Pedro Pinheiro, Dagur Falberg Johansson, Amuri Sachet, Andrea Suscini, Free Trader, and Justus Ranvier, who are great people to work with and cover the majority of Bitcoin implementations. There's also a lot of overlap in what we do and how we think. The important part, though, is the differences. Each Bitcoin client is unique and in its own way useful. And this is beneficial for everyone. It helps to avoid the echo chamber problem, and we avoid killing ideas that are before their time. More people competing on a friendly basis will benefit everybody, and this is what it means to have many implementations of Bitcoin. Bitcoin Classic is back. Bitcoin Classic is working on some pretty exciting things, and I think we have all come a long way. A very central part of Bitcoin is the transaction. Everything you do in Bitcoin will essentially use or depend on Bitcoin transactions. In the original Bitcoin 0.1 release, Satoshi Nakamoto included a design that is a very good indication of his intentions for the future. He included a version field for transactions. Today, 8 years after the fact, we are still using the exact same format that was introduced as version 1 all those years ago, so maybe we're not using his intention. So we do have a lot of issues with the current format, as you can expect after so many years. The issue at the top of the list is malleability, the bug in the way that signature validation is done in Bitcoin, which allows a third party to rewrite my transaction without breaking it before it gets mined in a block. And this has lots of subtle effects. Next to malleability, there are various other issues, and the most obvious one is that we have no space in the current format to add new features. The current format is in effect an evolutionary dead end. In this talk, I will introduce the flexible transactions format, which learns from the last years and takes the best part while fixing a lot of issues we have been suffering from. The best part is that it uses concepts and ideas that have been around for many years in and outside of Bitcoin and have become industry accepted. Those ideas have been successful because they allow future-proofing a system. Flexible transactions is a proposal that will not deprecate the current version of transactions. And they can run together for years. This means that we should have a very smooth way to get from here to there, where only people that actually use it will need a new version of their software. But I'll talk about upgrading strategies at the end. So what is wrong with the current transaction format? I mentioned malleability already. This is a design flaw in the current format for transactions. The basic problem of that is rather simple. It is that we have more than one way of storing transactions, which implies we have a conversion step between those, and this conversion isn't perfect, and some ways some changes may creep in if you convert from one to the other and back. To clarify what I mean with this, in crypto there's a definition that you need a canonical format. This is the one true way of formatting the data so that anyone looking at it will get the exact same byte for byte identical data. In Bitcoin, this has been decided by Satoshi to be the serialized format, which is used in a block and sent between nodes over the network, etc. Unfortunately, in the C++ code base and specifically in the signing part, this assumption of using one transaction is broken in one or two places. This assumption is specifically a problem in signing of transaction data. There are various inconsistencies as well in how something as simple as numbers are stored to disk. To understand this problem a bit better, let me make a simple analogy. Imagine you have a contract and you and counterparty agree on the terms over the phone. So you don't actually have a written account of what is said, but you have a recording of the phone conversation. So what you do is you hire somebody to make a written version of the agreement, and then you ask your contract counterpart to sign that paper. He comes back and says, no, I don't want to sign this because this is not how I remember our conversation. And he gives you his written version. To your surprise, it looks different in various ways than your written version. So the lesson learned here is that the only way to have a contract that nobody disputes after the fact is that you decide on one and only one true format. A canonical format that will be used by everybody. So this is very important. As Satoshi defined this for Bitcoin, to that any specific transaction, the only true format is the byte for byte data that is stored in a block and sent over the wire or saved on disk. With this assumption being broken in Bitcoin in places, this introduced the malleability issue. The goal here was that by removing the inconsistencies in signing and parsing this data today, we can solve 100% of malleability issues for transactions. So what is flexible transactions doing to fix that? Flexible transactions is a way to write a transaction in a very flexible format in such a way that we can define that the signatures are stored separately from the rest of the transaction. The way to make it flexible is to use a tagged system. Each variable we add to the format is in the form of a tag. Think about XML as an example of this. Here's a simple version of a transaction, as you could write it and serialize it. Flexible transactions is similar to XML and JSON in that it is a tagged format, which allows high flexibility and allows new items to be added without breaking old software. Whereas we improve on XML is that we use a binary format that uses the minimum amount of bytes and is optimized for speed. This is a best of both worlds solution, and if you ever worked with protocol buffers, you will understand this solution as it's 90% the same. We didn't actually use protobuf itself as it would be overkill, and it would be dangerous to depend on an external open source project not changing format for decades to come, because that's honestly how long I think this format will be important to Bitcoin. To solve the problem that this might be hard to use without libraries like a solution like protocol buffers supplies, we have added language support for this format as well. C# Java, C++ are already there. I played with Python last week as well. So how did this all work out? I think it's important to notice that flexible transaction is feature complete code that exists as part of Bitcoin Classic, but it should be pretty easy to merge it into other clients as well. The amount of changes needed is really not that large and is essentially limited to just reading and writing of transactions and also a little change in what part of transactions we sign. When I say that it is feature complete, I mean that it introduces a transaction format we can use for decades to come, and we don't need to change it. We can just add new tags in a backwards compatible manner and consistent manner if we need new features or future bug fixes. Consistency is key in FlexTrans. The simplest example is integer storage, where the current format stores integers in several different ways. FlexTrans stores all integers consistently in the same way. Consistency is also considered for future extensions. For instance, if we need a new version of script, we just add a new simple tag to the transaction without breaking the format. The same for many changes we can probably think of, but we haven't even thought about yet. This is a big improvement of the current format that has no more space for new features and reaches end of life because of that. The features that we coded and tested already are it fixes malleability, linear scaling of signature checking, hardware wallet support, this is also called fraud proofs, very flexible future extensibility, double spend proofs, this is actually a very interesting new feature, makes transactions smaller and supports the Lightning Network, and of course support for future increases like scripting version increases. All of this is accomplished with minimal changes, only the transaction format was changed and a small change in determining what data is signed. You can try this out today using Bitcoin Classic's nightly build for Ubuntu or wait for the next release which includes it. I have received a lot of good advice, many good ideas and kudos about my flexible transaction work so far, but in the end the work I do is irrelevant unless more people start using it. This is where we have to talk in the bigger community about how we want to roll out this proposal with the eventual goal of getting it into Bitcoin. First of all, we have to test it by using this in real life. I set up a testnet for people to use and check support of their implementation with the rest. The fancy thing is that the Genesis block of this testnet uses a flexible transaction in it, so downloading it will be a good test already. Additionally, I ship a testing application. It's a small application that can read and display transactions of different formats and save it in FlexTrans version 4 format to disk. Its reading code includes loads of Lintian style debug messages to debug third-party software for correctness. When we have more software that actually supports this format, we need to decide on how to really roll this out in Bitcoin. I really have no strong opinions on this, but it's very good to realize that wallets that do not need this format are not required to get a new version. They will continue to work just fine. Naturally, with the promise of getting smaller transaction size, they may want to upgrade anyway. I think it's a very exciting time to have going forward working on these kind of technologies, and I'd like you to participate. Thank you for listening.
Thank you very much, Tom, for your presentation. Now we do have Tom on the line and he's going to be able to speak with us.
Yes, I see a question. As Bitcoin Classic developer develops toward cleaner code, do you expect it will increasingly diverge from core and other implementations, or does it rebase from core periodically? I've been working for some time now on Classic, and every now and then it's important to look at some bug fixes from other implementation. I think the important thing to realize is that the amount of lines of code is quite substantial, and you can probably cherry pick all of those fixes without too many problems. I don't see any reason to continue to rebase on top of core, since they practically rewritten it for segregated witness. One of the core developers said that it actually touched every single part of the client. So I don't think that's good to have in Classic. But bug fixes are definitely possible. And I think that for the stuff that we're working on, which is the cleaning up of code, this is something that I hope we can share the code between, for example, Unlimited and Classic. I have another question, also from Anthony, and it's about flexible transactions. The question is, where are signatures stored? Are they in a separate Merkle tree, similar to segregated witness? The answer is no, they are not in a separate Merkle tree. So two things. First of all, the signatures themselves still are in the transaction. I think this is the one part where it's so much better than segregated witness. We don't have to move it into a separate data structure. The signatures themselves are just part of the transaction, but they've moved to the back of the transaction. So you just have to sign everything that goes in front of it. And that means that if you look at the network code that sends transactions, or if you look at the code that inserts transactions into a block, this doesn't change because the signatures are still there. So you don't have the downsides of putting it into a separate different data structure. It's actually a very interesting problem they have with this data structure in segregated witness, is since now a transaction is comprised of two different parts, they have to refer to each other. The original transaction has to refer to the malleability part. They have to refer to the signatures. So since there is a reference from one to the other, you can end up having some problems in somebody coming and breaking that link. So there still is, to answer your direct question, the second part of your question, there still is some Merkle tree needed for the signatures, because they don't actually are the signatures themselves are not part of the original Merkle tree data structure, because they're part out of it. And what I do is very simple. I define that the original Merkle tree is extended with the extra values from blocks Merkle tree. So I just append the signature Merkle entries to the original one. Sorry if that's a bit technical and not clear. I hope it was good enough. I have another question. If you want to add a new field, would this be a hard fork or a soft fork? If it's a hard fork, do you think it will be doable in the future? So technically speaking, the adding of a new field to flexible transactions is on the flexible transaction level not a hard fork. You can do it as a soft fork. But of course, this is not the end of the story. Think of a situation where we get all the miners to say, hey, we want to support the Bitcoin wallets, the online wallets, because they really help growth, and we think that makes the value of Bitcoin go up. So they say to all the Bitcoin wallets, well, you can create this new tag, which basically is number 11, and then you put your name in there when you create a transaction. So blockchain.info makes a transaction and puts its name in there. And at the end of the day, they look at all the transactions that were mined and say, well, so many % of the transactions were from them. We're going to give them some daily funds, and this is a percentage that they get. This is a very simple add-on, and it might be optional. You know, it's purely some way to pay extra. The thing is that this doesn't affect anybody in the way the transactions are parsed. So wallets don't have to care. And therefore this can trivially be done with just a soft fork. But on the other hand, you might come up with new tags that would definitely require all the miners and maybe all the full nodes to upgrade, and therefore you need to do that differently. So the technology of flexible transactions doesn't decide if it's a soft and hard fork. It has a lot of flexibility to allow you to do things as a soft fork. But of course, I think that personally, I think that we have a lot of innovation going on in the world of crypto, and we have a lot of options for new ideas to come in, and we have a lot of optimizations that can be done. And some of them will not be able to be done without breaking backwards compatibility. So what we have seen already said by Satoshi himself is the best way to do this is you set a block size, you set a block number, and at that block number, that is when you start introducing the new features. So for example, you can say that's a year in the future from the time we all agree on this new feature. And I think we're gonna have to do regular upgrades, and it's just a simple way of doing this without hurting anybody, without hurting the uptake. As Roger Ver said, you know, there's other ones out there that are doing lots of hard forks on a regular basis. I prefer to call this kind of upgrade of the protocol actually literally a protocol upgrade, because that's exactly what's happening. You're coming out with a new feature, and you have to either force everybody to get a new client, or as in the case of a soft fork, you basically don't have to upgrade everybody at the same time. The problem with calling it a hard fork, I think, is that if you look at this from a very negative point of view, because that's what it is, right? If you call a protocol upgrade a hard fork, you're basically saying, I'm calling this by its failure mode. I'm calling this a hard fork because if it goes wrong, it forks. And the reason I'm saying that is because if you look at the protocol upgrade as you can get it in the ideal situation, it's just at this point we have new rules that are being that govern Bitcoin, and all you get at that point is people continuing the blockchain on the new rules. There's absolutely no reason for that to cause a fork in the chain. So I have no idea why we have started calling this a hard fork. It sounds very negative to me.
Thank you very much, Tom, for your presentation today.